r of x equals x minus 1 over x squared minus 4. And what I want to do is I want to develop a rough sketch of what this graph looks like. And so far we've been learning some different elements that will help me determine what that graph is. We can look for its intercepts, both its x and y intercepts. We can test to see if it's symmetrical with the y-axis or with the origin. We can look for its asymptotes, both its vertical and its horizontal asymptotes. And based on the information, that will give us a fairly good idea what this graph looks like. The first thing I might do is I just might factor it down so I can see what the polynomial, what the rational expression looks like. Here, once I've factored it down, I can determine that my domain is restricted. X cannot equal 2 or negative 2. And so that's important when I'm drawing my graph. Its intercepts. Well, I can find its intercepts if I set the function equal to 0. I see that x equals 1 and y equals 0. So there I have a solution to my particular graph. Now let's go ahead and remember that. So I have a solution at the point 1, 0. I can look also for its y-intercepts by looking at what happens when I evaluate the function at 0. And that equals 1/4. So I know I have a point 0 and 1/4 also on this graph. So there was some information I was able to find. Its intercepts. Next we can determine if it's symmetric with the y-axis or if it's symmetric with the origin. In order to do that, I'm going to evaluate the function at negative x. And evaluating it at that, I see that this function is neither my original function, r of x, nor is it negative my original function, r of x. And so because of that, I see that there is no symmetry with respect to either the y-axis or to the origin. The next part we can look at is looking at its asymptotes. First of all, we can look at its vertical asymptotes. And its vertical asymptotes will be determined where the denominator, when the rational expression is in its reduced lowest form, and it is, I can't factor it any further. I look at the denominator and find out where does it crash, where does it go to 0 at. And it crashes at negative 2 and positive 2. So I can go ahead and draw some vertical asymptote lines at that point. The next we want to look at the horizontal asymptotes. And the horizontal asymptotes can be determined if it's a proper or an improper rational expression. And this one is a proper rational expression, meaning that the degree in the denominator is greater than the degree in the numerator. When that's the case, we know that the line y equals 0 is a horizontal asymptote. And take note here that even though I have a horizontal asymptote here, this point, the solution 1, 0, that does cross through that asymptote in that particular case. So now I have an idea of how the graph lays out. Now I just want to determine what does the graph look like in all these regions. I have one region, region 1, region 2, and region 3. Well, region 2, I can get an idea of what's happening, that I know it crosses here, and it also intersects this point. So in order for a graph to do that, and it also has to approach my asymptotes as well, I know that it's going to have a little bit of a feel like that. Okay, well what happens in region 1 and region 3? Well, usually what I like to do is I like to choose a test point. Maybe I'm going to choose a point that's way out here, like negative 10. Let's find out what's the value at negative 10. So negative 10, that makes it a negative 11 over a positive 121, 116, 117. So a very, very small number. Maybe if I choose a number closer to this asymptote, like negative 3. Negative 3, take away negative 1, gives me a negative 4, all over a 5, which is a slightly larger number in value. So doing that, choosing a couple test points, I see that this graph is down. 1, it's negative, and 2, as it's approaching this asymptote, this value is approaching negative infinity. And I found that out by choosing a couple of test values. And likewise, over in region 3, I can do some test values as well. If I want to put in a number like 2, or a number like 3, what happens when this function is evaluated at 3? 3 minus 1 is a 2. All over 5, that's 2/5. And if I choose a number like 10, 10 minus 1 is 9. 9 divided by 96. That's a smaller number. It's positive, so I know it's going to be in the positive aspect of the region, but I also see that as I approach infinity, my value is approaching 0. So the graph on this side looks like that. So going through those steps in a very methodical and organized manner, I had the ability to kind of get a good idea what this rational fraction, rational expression looks like when we graph it out.